Okay, see guys. Yeah, we will start with this. Okay, we will start with measurement of small angles. Those who don't have this idea, please check. Okay, so we'll start with measurement of angles. This is your PDF number 3. Okay, I'm talking exactly from there. So how do we measure angles, and we'll talk about that. Okay, obviously you have already some ideas. Okay, we use protractor to measure the angles. The protractor is going to tell us the angles. Okay, in a unit, that is your degrees. We have this line here.
Sir.
Yes.
Sir, will you be recording, because Abhijit won't be able to join, sir?
Yes, I'll be recording. But you are also Abhijit, right?
Yes, sir.
Okay, two Abhijit.
Ghosh won't be.
Oh, okay, fine. I'll be recording. Yes. Okay, so see. So I told you that yeah, we have this instrument, which is called protractor, of course. Here we have the 0 mark. Here we have the 90-degree mark. Oops, what happened? Okay, this 90-degree mark. This is 180-degree mark. Okay, and we measure angles like this, right? We go anti-clockwise. Okay, to measure positive angles. If we go clockwise, then we are measuring what is that? Negative angles. Okay, we have negative angles also. But let's stick to what is this angle. See, this is very simple for us. The angle made at this point, right, where the two lines they intersect. We measure the angle. We call it 90 degrees. Okay, the unit here is degrees, and you already have some idea how much is 1 degree here. Okay, this much is 90 degree. From here to here, maybe 1 degree. From here to here, 45 degree, right? Okay, this is, we already have some idea. Okay, how much is 1 degree, 2 degree, 4 degree, and so on. Okay, now the degree is not the only unit where we can measure our angles. We have another unit which we call as radians. Okay, so what is radians? See, in radian measurement, okay, we use pi. That is indicative of actually 180 degrees. It's a different unit. Okay, altogether different unit, but pi also represents an angle that is equivalent to 180 degree. Pi by 2 for us represents an angle of 90 degree. Pi by 4 we can have which is how much? 45 degree. Okay, pi by 6 also we can have. Pi by 6 is 30 degree. Okay, and then how much we have? Pi by 6, 4, 3, 2, 3 also, no? Pi by 3 also we have, that is your 60 degree. Okay, so you already have some idea about how to measure angles. Okay, now what we are going to do is we are going to learn something called how do we measure very small angles, okay, which is much smaller than 1 degree, so we are going to do that. Okay, but before I proceed, let me just show you. We can convert anytime degree into radians and radians into degrees by using this. Okay, see, already I have written pi is equal to 180 degrees, so that means I can write 1 radians. Okay, this is actually pi radians also, we can call it pi radians. So 1 radians will be equal to how much, guys? We know it is 1 degree, 180 degree by pi. Okay, where the value of pi you have to take is 22 by 7. Sometimes approximately we take 3.14. we can use that. Okay, so this is how you convert your radians into degrees. Example I'll give you. If I ask you what is 50 radians, if I ask you, okay, it's an angle, but equivalent to how many degrees? Your answer is 50 radians is equal to 50 times of 180 degree by pi, because by pi, because 1 radian is so much. 50 radians will be 50 times of this, right? So that's how you convert your any amount of radians to degrees. Okay, just multiply by 180 degree, divide by pi. Okay, so how do we do the opposite way? See, the opposite way means 180 degrees equal to how much? Is equal to pi radians. So if I want to convert, I have to know how much is 1 degree equivalent to, right? So 1 degree is equivalent to pi by 180. Don't write here degrees here. If you write here degrees again, here again degrees, that is wrong. Okay, so only 1 degree. I'll just show you how we are getting this. Okay, so let me just show you once. See, 180 degree can be written as 180 times of 1 degree, so that's why and anytime we can also write 1 degree is equal to pi by 180 radians. Okay, so now if I ask you convert degree into radians, suppose convert 30 degree into radians, you will say 30 degree should be equal to 30 times of this,
30 times of pi by 180.
30 times of pi by 180 radians. Okay, yes. Okay, so this is quite all right for us. Okay, you have done this already. Okay, now let's go to very small measurements. Okay, so let me show you what do I mean by very small measurements. See, let me just show you here what is 1 degree. It will be approximate, of course, not very accurate, but let's say this is our 1 degree. Okay, this angle here is 1 degree. See, 1 degree. Now I don't want to talk about 1 degree, I want to go to much smaller angles, okay, and that name given to the smaller angles is this one. See, we call it arc minute first of all, okay. This is our starting of smaller angles, okay. I'll tell you what is 1 arc minute, okay. 1 arc minute, see, we write like 1 and dash, that's how we represent 1 arc minute. 2 arc minute will be 2 times 2 and dash, okay. So what is 1 arc minute? See, you take this 1 degree, whatever angle it is, okay, and you divide into how many parts? You divide into 60 parts, okay. So you are going to get an angle which is very, very small. Example of what is the meaning of division, let me show you that. See, you have taken 60 divisions, okay, here, just imagine, okay, it's very difficult actually to imagine also, it's such a small angle. Just imagine, I have 60 divisions within this 1 degree of an angle, okay. I am drawing only few, okay. Drawing 60 is not possible right now for me, okay, no chance, okay, that I can draw, okay. But can you imagine if I have 60 divisions, the value of only one such divisions, the value of the angle made by one such divisions, right, that is known as your 1 arc minute, okay guys. So is it clear? Is your arc minute clear, guys?
Yes, sir.
Okay.
Yes, sir.
I take 1 degree, divide into 60 parts. One part of that 60 divisions is what is we are going to call it as 1 arc minute.
Arc
okay.
minute.
Yeah, arc minute. So this is how you are going to
Arc
convert.
minute.
Yeah, this is how you are going to convert. Okay. 1 arc minute is equal to so much. So 10 arc minute will be how much, guys? Easily you can tell me now. 10 arc minute will be equal to 10 times of 1 degree by 60. Yes. So this is how you can convert your arc minute into your degree. Okay. Arc minute is not time. Okay. You must be thinking, no, it is minutes, so it is time, but no, arc minute is an angle measurement. Okay. Now already you can see, right, it's a very, very small angle. That is your 1 arc minute. Imagine I take that arc minute. Okay. Very difficult to draw again for me, but let me still try. Imagine I took that arc minute, very, very small angle. This is your arc minute. Okay. Can't even actually imagine, no, such a small angle. I take that 1 arc minute, I divide that again into 60 parts. Okay, so I'm going to get a very, very small angle here. See, I cannot even draw that 60 parts, right? But can you imagine now this angle? Is it small or very, very small?
Very, very small.
Very, very small. Much small. Okay, too small. Okay, cannot even imagine. No, that is what is known as 1 arc second. I hope you understand what is 1 arc second, right? Arc second. Okay, let me write. So
Yes,
we have
sir.
1 arc minute and we have 1 arc second. Okay, so this is what we have as your small angles. Okay, so I can easily write this one. See, guys, now 1 arc second is equal to 1 arc minute divided by 60. So it's a very small angle, but we already know in place of 1 arc minute I can write 1 degree by 60 again. So this is what we have. Therefore, if I take 1 degree and divide into 3600 parts, that is what is known as 1 arc second. Okay, if I take 1 degree, divide into 3600 parts, no, one part of that 1 degree which is divided into 3600 parts is known as 1 arc second. Okay, I think so far we are doing fine, right? This is how we talk about angles. Okay, I'll give you an example here of how do we write these angles also. See, suppose I tell you 1 degree, let me just take 1 degree and then I write here 54 arc minutes, and then let's say I write 3 seconds. Do you understand how to read? This is what, guys, can you read it? This is an angle. Okay, so all together is an angle. Yes, so what is this? 1 degree, 1 degree, then
54 arc.
54 arc
Arc
minutes.
minutes.
For 3 seconds.
And
3 arc seconds.
3 arc seconds. Okay, you can read like that, or you can just call it 3 seconds also. Okay, we will understand that. So yeah, this is what we did. What is this? Okay, now let me show you. Okay, how can I convert? Okay, very quickly I'll do that. I'll just show you how to convert. Let's convert into degree. Okay, let's convert into degrees. Okay, it's like this. See, guys, so already I have 1 degree, so I'm going to write 1 degree. I don't have to convert that 1 degree, we already have that as degrees, but 54 minutes can be converted, right? So what is 54 minutes, guys? 54 minutes is
54 by 60
by
degree.
60. So this has now become degree. And what is that? 3 minutes, sorry, seconds. 3 divided by 3000 and
3 divided by 300.
yes. So look at this. Now this also has been converted into degrees. This also has been converted into degrees. This also has been converted into degrees. Now if I add all of them, then I get the overall angles, and that is what is your what measurement in degree measurement. You're not going to multiply them, okay, you're going to add them. I'll tell you what is the logic here, why we are adding. I think this part is clear, right guys, this one?
Yes, sir.
Okay, so this one is clear. So why we are adding, okay, because it's like this. If I tell you 1 minute and 10 seconds, okay, then I tell you, okay, convert into seconds. What do you do? Convert into seconds. What will you write? 60 seconds
60 seconds plus 10 seconds.
plus 10 seconds, so total is 70 seconds. Okay, then I tell you convert into minutes. How will you convert into minutes, guys? 1 minute already there. 10 seconds is how many minutes?
We'll divide by 60.
10 by, but this also now it has become what, minute, no? Now you add it, yes, so
Yes,
it is
sir.
like 1 minute plus how much? 1 by 6, no? Plus 1 by 6 minute. How much is that? 6 in 1, 7 by 6 minute. Okay, so see, we have converted like that. Okay, so I can convert here also. We can just do anything you want. If I want this, okay, 1 degree 54 minutes and 3 seconds, no, I want to convert into seconds. Tell me, how will I do it, guys? I want to convert into seconds. How much is 1 degree in terms of seconds? Now I think if you have brain, you can tell me. If you have
3600.
very good, yes, 3600 seconds. It is equal to how much? 1 degree. Can you say? I'm not dividing, okay? Yeah, so I've converted 1 degree into seconds. Plus, how do I convert this 54 minutes? 54 minutes into how much? 60. That has become now what? Now it has become what, guys? Seconds. Plus I already have 3 seconds. So now if I add these 3 of them, now I'll get the answer in what? In seconds. Okay, I'm getting the answer in arc seconds measurement of an angle. Okay, I think this part is clear, right? So I think we can proceed. Okay, is it clear, guys, this one?
Yes, sir.
Okay, so now this was all in your PDF number 3. Okay, so I'm going to go now PDF number 4. Okay, PDF 4 I will not go, you can do it. Okay, you got enough ideas. PDF 5 I'll go. Okay, PDF 5 is this, guys. Say PDF 5 is about your larger measurement. Okay, large distances. Okay, so check. See, why do we need large distances? Very quickly I'll tell you. If I'm measuring the distance of a okay, why it is lagging, right? in the screen, whatever I'm doing is coming very late in the screen. Okay, now I think it's okay. This line doesn't look straight. Okay, see, so what I was talking about, what about large distances? Why do we need large units actually? Okay, so see, if I want to measure the length of a road, okay, road from here till where to say, let's say from here to Guwahati, okay, from Shillong to Guwahati, no, you cannot take a centimeter scale, right? This is a scale which we use in your copy, no, this is centimeter scale. Okay, telling me the answer in centimeter is a very bad idea, right? Okay, length of a road. Okay, because why? Centimeter is a unit or it's a very small unit?
Small unit.
Okay, but small
Very
unit,
small
but
unit.
corresponding to measurement of what? Length of roads. Very bad unit. Okay, very bad. It's a very small unit. Okay, doesn't justify. Okay, because you know what, I'll be telling you answer like this. See, 1000000. I don't even know how many zeros I'm putting. I'm just writing centimeters like this. See, very bad way of writing. Okay, but of course writing 100 kilometers makes sense to length of the road. Okay, 400 kilometers makes sense. Kilometer is a very nice unit. We have some idea about kilometers, centimeters, of course. Okay, but imagine I want to measure very small distances. No, then I will not even use centimeter. Much smaller units I'll use maybe millimeter. I can use micrometer. So we need, because we can measure very small lengths, no, so we need small units. Okay, now imagine we are going outer space. Okay, so we have, this is the planet Earth, and then suppose I am talking about distance between Earth and Sun. Okay, the distance between Earth and Sun. Okay, let me just try to write it down. Okay, 1 point, or not 1 point, okay, 4 point, okay, 1.5, let me write, into 10 to the power 11 meters. Okay, this is not a good way again of writing. Okay, because see, which is the unit I'm using, guys? I'm using what unit? Meters.
Meter.
Okay, and it is the distance between what and what? Earth and Sun. I already have a power which is very huge. Okay, so you can already understand, no? If I really want to write this, it will look like 1.5, then followed by how many zeros should I write? 10 or 11? If I'm writing like that, guys, 1. So 10 zeros. 1 2 3 4 5 6 7 8 9 10. and then meters. No, this is not a good way of writing. Okay, so already our measurement is such a huge measurement of length, so automatically your unit is a very bad unit that we have chosen. Okay, so that's why we need bigger units of length, and that is what we are going to talk about. Okay, we specifically have these 3 bigger units of length. We start with the first one, very simple. Okay, we call it already, I think you know, 1 AU. 1 AU stands for astronomical unit. Yeah, astronomical unit. Okay, so what is astronomical unit? The definition is very simple: the average distance between the earth and the sun. Okay, so let me draw sun. Why I cannot click here? Okay, so oops, that's not sun, this is sun. Okay, so the average distance between the earth and the sun, no, this distance. Okay, calculate it like this, and we are not even worried about the size of sun or size of earth. Okay, because we can neglect them right now. So I can measure from the edges or from the center, doesn't matter right now, but it's an average distance. This distance, okay, from the earth till the sun is what is known as 1 AU. So obviously 1 AU is a very big unit of distance, and now I can talk in terms of AUs. Okay, so what do I mean by that? Let me just explain. I can tell you that the distance between earth and our Jupiter, okay, let me draw Jupiter also. Okay, Jupiter, earth is here, Jupiter is somewhere here. Okay, so let me tell you how much is that, guys. See, the distance between earth and Jupiter is 4.2 AU, and that is again very, very huge, of course. Okay, but see, we are talking in terms of not meters, but we are talking in terms of AU, no? And you can understand the meaning of this already. That means the distance between earth and Jupiter is how much? Is 4.2 times larger. 4.2 times larger of what? Larger than, or let's say 4.2 times of times of earth and sun. Okay, so this distance is 4.2 times of this distance. Okay, so that is why we have a very nice unit, AU. And the moment I speak about AU, right now you already get some idea. Okay, if I tell you 10 AU, you already in your head you have this idea, right? 10 AU is a distance that is 10 times of the distance between the earth and the sun. Okay, so that's why, see, our units are very nice now, properly placed, and we can use AU and AU, okay, whenever we want. Okay, now we can obviously have the conversion. How much is 1 AU, okay, in terms of meters or kilometers? So I'm just going to write one, okay, number, just check. Yeah, the number is 1 AU is actually writing 1.496 into 10 to the power 11 meters. Okay, which I can approximately take for your calculations 1.5 into 10 to the power 11 meters. Okay, if I want to write in kilometers also, I can do that. 1.5 into 10 to the power 9 kilometers. Okay, I have increased my, is it correct? No, 9, it will 9 or 8, 8, no? 8 times. Okay, 8 times of kilometers. Okay, so see, I've increased my unit, my numerical value is going down. No, that always happens. If you use bigger units, you'll get smaller numerical values. Okay, so this is just
so this is the value of 1 AU.
Yeah, this is the value of 1 AU. 1 AU is equal to so much distance in terms of meter. Are you clear?
Yes, sir.
Okay, yes, so this is what is 1 AU. Okay, then okay, let's look at some more units of distance, much bigger units. Okay, because our galaxy, right, our solar system, let's say you take earth, you take sun, you take all the 8 or 9 planets that we have. Okay, then yeah, AU is quite good. AU is a very fine unit. Okay, till now we are doing fine because AU can help us to calculate the distance between earth, sun, and then any other planet. Okay, it's very easy. Okay, AU gives you proper idea about what is the distance between sun and any other planet. Okay, but our solar system, if I start comparing it with our galaxy, then automatically what will happen, guys? AU becomes a good unit, or it again becomes a smaller unit.
Smaller unit.
Just imagine distance between Milky Way galaxy and some other galaxy, you know, so it's going to become very, very small. Okay, the AU units. Okay, that's why we have a much bigger unit, and for that we have we call it light year. Okay, so light year, LIGHT, light year. Light year is not a unit of time. Okay, don't think it is year. Okay, light year is not unit of time, it is actually unit of distance. Okay, so yeah, so what is 1 light year? See, I'm trying to explain to you what is 1 light year. The symbol is 1 L and Y. Okay, 1 L Y, that's how you can write. So let me tell you what is this. Say, It is the distance traveled by light. Let me write it down. Distance traveled or covered by light. By light while traveling in vacuum, of course, in 1 year. In 1 year. So can we calculate this distance, guys? Yes, we can calculate this distance. To calculate the distance covered by anything, we have to know its speed and we have to know the time. Okay, because speed is equal to distance by time. So distance will be equal to speed into time. Okay, if I want to calculate distance, I will multiply speed and time. Okay, so what do I want to calculate, guys? Now check. I want to calculate the distance traveled by light in 1 year. So I have the time information, that means how much distance light will travel in 1 year, and I also know the speed of light, yes or no? So we have both the information. See, we know the speed of light, we know the time, so I can calculate the distance traveled by light in 1 year, and whatever is the distance traveled by light in 1 year, I'm going to call it what, guys?
One LY.
One light year. Okay. So Sambhav is clear now. Sambhav, light year is clear.
Yes, sir.
Okay. So see, okay. So how do we calculate this? See, so speed of light is 3 into 10 to the power 8 meters per second. 1 year. Let me just write here 1 year. Okay, but obviously I cannot multiply them. They don't have same units in terms of time here. So I'm going to convert. Check. Okay, 3 into 10 to the power 8 meters per second into 1 year. 1 year is like 365 days. Every day is like 24 hours. Every hour is like 60 minutes, and 60 minutes, every minute is like 60 seconds. So finally I've converted, everything in seconds, right? So the seconds and this minus second inverse gets cancelled. Now our only unit left is meters, and yeah, that is distance, no? So that is what we get. Okay, so let me write it down exactly how much do we get. I will not calculate, you have to remember this. 9.46 into 10 to the power 15. Tell me. How much? 15. Okay, you remember, good. Okay, 15 meters. Okay, this is what is known as 1 light year. This is the amount of distance light will travel in 1 year. Okay, it's very huge distance. Okay, you cannot even imagine actually. You have to sit on top of, if you sit on top of light and travel, no, you will reach so far away in 1 year from us. Okay, so it's a very big distance. Okay, then yeah, after this I told you, right, there is a much bigger unit also. Okay, much bigger also we need. So for that we have a name, we call it 1 parsec. That is another unit of distance. So I'm going to explain to you now, okay, what is the definition of 1 parsec. Okay, so see, imagine I want to talk about this. Okay, see, this is Earth. I have Earth here, very tiny Earth. Okay, in comparison to solar scales. So we have Earth, we have Sun here, very big Sun, of course. Okay, let me not even do like that. Let me just take them as points right now. Okay, this is Earth, point in our galaxy. Then we have Sun, almost like a point again, Sun. Okay, now what is this distance? You already know, right? This distance is how much, guys?
1
AU. Okay, this is 1 AU, astronomical unit. So everybody knows about this. Okay, now suppose, okay, I am at certain distance here, say, okay, at certain distance right now, and I'm trying to make an angle for this arc at certain distance. Okay, so this is what I'm going to start calling as what? Radius of the arc, right, guys? Check. That's the arc. This is arc. The length of this arc is how much? 1 AU. Yeah, 1 AU. Okay, and I have a point where from where I'm measuring this angle, okay, subtended by the arc. Okay, at certain point, let's call it P right now. Okay, so my question is, suppose, okay, looking at the diagram, what do you think, guys? What is the angle? Just tell me, just roughly guess. Any angle, whatever it feels, we feel like. What do you think?
40.
40. Okay, fine. 40, 45. Okay, 40 degree. Let me write. Okay, 40 degree. Everybody's happy, right? Okay, it looks like 40 degree. No. See. Okay. I want to make. Okay, I want to make the angle subtended by this arc. That is your 1 AU. Okay, I want to make this angle not 40 degree. Okay, I want to make this angle very small. You know what I have to do? I have to go very far. See, I'll go here. See, I'm going much far now. Okay, now automatically you will notice the radius which this arc makes, right? So that the angle subtended by this arc at certain point is much small. Let's say only 20 degree now, right? So now this radius, what do you think, guys? The radius is becoming big or small? What do you think?
Big.
Big. The angle subtended by this arc is becoming small or big?
Small.
Small. Okay, now you just imagine that I really want to go so far. Okay, I cannot even show you on the screen. Okay, but let me try. I'm going so far. Okay, So this is a wrong diagram, but still, okay, I'm going so far that this angle is exactly 1 arc second. Can you understand? Okay, I want to go so far from this arc. No, this is our arc, which has a length of 1 AU, okay, and I want to go really so far, okay, such that the angle is going to be what, 20 degree, 30 degree, or 1 by 3600 degrees. Just imagine, it's a very, very small angle. What do you think, guys? I'm going far or I'm going very, very far?
Very, very far.
Very, very, far. Yes, the distance how far you have gone from this arc, it is known as 1 parsec. Are you clear what is 1 parsec, guys?
Yes, sir.
Okay, so what is 1 parsec? Now tell me, is 1 parsec the length of the arc? Yes or no? Is 1 parsec the length of the arc, or it is not the length of the arc? No, it is not. It is not the length of the arc. So what it is? It is the radius, right? Do you agree or not? It is it is the radius. It is the radius of what? It is a circle. Okay, by the way, see, I'm not drawing the whole circle here, but actually radius means a circle only, no? So it is the radius of what? Radius of a circle. 1 parsec is known as the radius of the circle, where the arc of the circle of length 1 AU, okay, subtends an angle of how many degree? 1 arc second at the center. This is like the center of this entire circle that I'm trying to draw. Okay, I'm repeating again. If you're confused, see, take Earth, take Sun, find a point, okay, which can act like the center of this arc, okay, because it is a part of a circle, so I can treat it like a arc, and go so far, okay, go so far that you start making an angle of around how many degree, guys? 1 arc second. You really have to go so far, and then now this distance, whatever distance you have gone so far, I'm going to start calling it as what? As 1 parsec. So that is the definition of 1 parsec. Okay, it's a very big unit of length. Okay, now let's really calculate how much is this 1 parsec, because we really don't know what is 1 parsec, but we can find it. Okay, I'll give you a hint of how to proceed. Let's call it theta right now. This is theta, so please check. Okay, now you must be knowing this one. See, if I have an arc here like that, and then this is the length of the arc, this is the angle theta, and is the radius for this arc, you know. So what is the relation between them, guys? I think you know by now, no? What is that, guys? Tell me. The angle theta, yes, should be equal to, waiting, length of this arc. Every time remember that, length of
divided by radius.
Divided by radius, this radius. Yes, okay, so this is the one. Say, so now I'm going to use this and calculate the radius, because that is my point, no? Because I know already the radius is here, so I'm going to write here the radius equals to how much? Length of the arc divided by theta. Okay, so I'm going to write like that. Now you tell me, when will I start calling radius to be 1 parsec? I can say that the radius is 1 parsec if length of the arc is how much, guys? 1 AU. Yes, and then theta is how much? 1 arc second. 1 arc second. Yes, this is what we have. Now it's clear. No, I think 1 parsec is clear now. Now we can find what is 1 parsec. Okay, so 1 parsec. Okay, by the way, one mistake is there. Okay, already I made a mistake already. I'll tell you what is the mistake. See, whenever I write this formula, no, whenever I write this formula or you write the formula, you are not allowed to use any other units, but always use a unit of what for the theta? Radians. You are not allowed to use arc second. You are not allowed to use any other units, but you have to write here how much? Radians. Okay, so this has to be converted. Okay, this I'm writing here right now arc second, but it has to be converted to radians. Okay, so that's our first job. Yeah, so that's our first job. Okay, so 1 AU can be written as 1.496 into 10 to the power 11 meters. That is quite all right, but this cannot be written like that, so we have to convert it. Okay, so let's try to convert it. 1 arc second is equal to how much, guys? We know it is 1 degree divided by 3600. Yes. Okay, now I want to convert this into radians. So what should I do, guys? 1 degree is equal to how much? 1 degree is equal to how many radians?
Pi radian by
pi by 180. Pi by 180, right? So now we will get radians. No, so 1 degree can be replaced by this. Okay, this one. So 1 degree, in place of 1 degree, I'm writing how much? Pi by 1 80. So I've replaced my 1 degree. See, this 1 degree has become this one, pi by 180. Okay, now it is a radian measurement already. Okay, but I still have this 3600, so I'm going to write here 3600. I can come and replace now that over here. See, I'm going to write here pi divided by 180 into 3600. Then in place of pi, you know, I can write 22 by 7. Okay, after writing all these numbers, when you calculate, you'll get 1 parsec that we're trying to find is equal to, in terms of meters. Okay, 1 parsec is equal to, let me check, I have forgotten the number, 3.0. Good, you remember. Okay, very nice. Okay, my memory is very bad. Okay, good, you remember. 10 to power 16. Okay, so this is what we get as parsec, guys. See, so are you clear what is parsec? So it is a distance, of course. 1 parsec means so much distance, 2 parsec means double of that, 3 parsec means 3 times of this distance. No, so that is what we have. Okay, so guys, can I say it is clear, the angle measurement, oh sorry, large distances measurement is clear, right, for all of you?
Yes, sir.
Okay, then PDF 5 is covered. PDF 6 is about these conversions only. Okay, so I am not going to show you that, please do it. Okay, then after that also, if you have doubts, please ask me. Okay, but can I say it's like that, Jyotirmoy, can I say you can do it, number 6 now?
Yes,
PDF,
sir.
you can do now. Okay.
Yes, sir.
Okay, then let's go to number 7. Okay, so number 7, I'll tell you what is this. Okay, see, I'm going a bit fast, okay guys, because I have tuition again, I told you, no, class 12. So I was talking about this one, measurement of large distances. How do we measure large distances? Okay, so see, measurement of large distances. Okay, we cannot directly measure large distances, no chance, directly not possible. You cannot take a scale from here to moon, okay, and calculate the distance between earth and moon. No, not possible. Okay, so you have to follow what kind of method, guys? Direct or indirect methods? Indirect method. Okay, indirectly we have to find, no, some way. Okay, so I'll show you. Okay, the method that we are going to use is called parallax method and parallax. This is the spelling. Yeah, parallax method. Okay, so what is parallax method? See guys, parallax method is this. Okay, so you must have noticed, if I want to see an object, okay, I have 2 eyes, of course, this is the eye, this is the eye. Okay, then if I close my one eye, no, or let's say I'm looking at the object and I shift to the left. If I okay, wait a minute, bad diagram. Okay, let me just draw one eye right now. Okay, I want to see the object from here. If I see the object from here, it appears there towards my right. And when, you know what, and when I see the object from the right, if I go here, see, this is my new position. If I go there, the object appears to be where?
On the left.
On the left. No, object is not moving. Okay, you are moving. So when we shift our position, right, from the observer, right, when the observer shifts his position, or let's say slides his position left and right, no, the object also appears to move left and right. Okay, in the opposite direction. No, this is what is known as what, guys? We call it parallax. Are you clear what is parallax?
Yes, sir.
Yes, sir.
Okay, yeah, so we are going to use this method now, okay, to measure indirectly very large distances. Okay, so I'll start with the first one. It is there in the notes, please check. Okay, very nice idea. Okay, so see, before I proceed, I will draw the diagram. I am going a bit fast, but I hope you are catching. Okay, some of you're getting me what I'm trying to do.
Yes, sir.
Okay, so Sambhav is also understanding good. Yesterday Sambhav, okay, was saying that very bad, no, physics. Your head was paining, no, Sambhav, yesterday?
Yes, sir, first day.
But do you understand significant figures now? Did you go through?
Yes, sir, little.
Little? No, it has to be fully cleared. You cannot be little cleared. You check the rules. You just read the once now. Yeah, okay, just read the rule once. Just casually. Don't be like, what is this and all. No need. Just read the rules and do it. You should be able to do. Okay, let's say,
Yes,
so suppose, okay, I want to measure distance. Okay, see, I want to use this parallax method. I want to use measure distances between Earth, okay, and let's say some planet, or let's say from Earth and Moon. Okay, I want to calculate the distance between Earth and Moon, or some nearby planets. Okay, not very far, but nearby planets. So let me show you what is this method. Okay, this is Earth. The green thing that I've drawn is Earth. I have the planet also. Let me just show you, where do I draw it. The planet is somewhere here. This is our planet. I want to measure this distance, the distance between the Earth and the planet. Okay, I think this part is clear. Okay, now see,
Yes, sir.
Okay, this is what I want to find. Okay, so now check something. See, you will agree with me, right? Very far from Earth, and this planet, I can always see or look into a star which is very far, right?
Yes, sir.
Okay.
Yes, sir.
Now try to understand this, my next diagram. Okay, if you understand the next diagram, everything will be very simple. Okay, imagine I have a point here that is called F, and imagine I am going to look at this point F from 2 points, means from here and from here. Suppose, okay, I can change that also. If you don't like that, I can look from here and here also. Okay, I'm going to look, okay, at this point. It is very close right now, the F. Okay, so I'm going to look like this. Yeah, I'm going to look like that. Try to concentrate on these 2 arrows. Please check what will be the effect. Okay, so yeah, I have this 2 arrows like that, no problem till now. And yeah, you can easily tell me, yeah, it is making some angle here right now. Okay, so we have this angle, that's also not a problem. But check, something very nice will happen. Okay, whatever is the angle, okay, you can just tell me. It's right now some rough value of this angle, guys. Okay, let me just write 30 degree. No, so that's quite all right. I think you understand what I'm trying to do, right?
Yes, sir.
Okay, now think about this. I don't have this point F here. Let's say I have this point very far. Okay, very far. Okay, let me put it like that. That is the point F. Now I want to look at that point F again. Okay, from these 2 points, from here to here like that, from here to here like that. Now you tell me, guys, is the angle subtended at this point here, is it still 30 degree or much less?
Much less.
Much less. Okay, if I continue going far and far, do you agree that from these 2 points, okay, A and B, okay, let me write here A and B, if I go very far, too far, okay, very far, you know what will happen? Can you guess what will happen to these arrows? They'll make some angle. They'll make 0 angle. What do you think? Or almost 0?
They will not make angle.
So how much? They'll not make any angle means what? They will look like parallel, right?
Yeah.
Yes or no? Because
Come all straight, sir.
they'll look straight to each other, right? Yes or no? Can you understand my point?
Yes,
But do you realize that they are still looking at different star, or they're still looking at the same point? I want to say are they still looking at 2 different
Same
things?
point.
We are still looking at the same point. But these 2 arrows, they have become what, guys? Parallel. So now you tell me, this F and this F, they are different or they are same points? Same points. Okay, right? Is it clear? This point, is it clear?
Yes, sir.
Okay, so that is what is going to happen now, guys. See, I have this Earth here. You can see this is Earth. I'm going to look, okay, with a telescope. You know what is a telescope? Of course.
Yes, sir.
I can align a telescope like that. Okay, let's say this is where the direction of the telescope is. Okay, I'm looking in this direction. So I want to look at this F, okay, from point A, that is location on Earth. So this is how it's going to look like. See, let me tell you, it is somewhere here. Okay, this point F. See, and what is point F? You should understand, it's a very far away star, okay, from Earth and Sun, of course. Okay, so see, we have this. Now I want to look, okay, not only this point F from point A on the Earth, but also from another point, which is what? B on Earth. Can you understand?
Yes, sir.
Okay, so when I take this arrow, right, it's
Yes,
again
sir.
going to look. Now you tell me, F is close or very far? Very far. That's why these 2 rays, right, these two, right, that I'm drawing here, they will be parallel to each other. But is this F or F dash, or they are same thing, guys? These 2
Same, sir.
same. Yes, and that is what I'm trying to say. Okay, so yeah, we got this idea. No, now understand this. Okay, so here I have a telescope. Let me just show you. Already I have a telescope here, placed here on Earth. Here, this is also a telescope placed on Earth, okay, focusing on the planet, or sorry, the star, distant star, this one F. Now you know what, I'll take another telescope, or let's say I'll rotate this telescope, and I'll look into this point P also, the planet P, or let's say the moon P. Okay, this one, this is let's say right now it's moon. Okay, now you guys tell me, okay, how many telescope I'm using? I'm using 2 telescope at this location called A, one to focus on that distant star, and one to focus on the planet. Then from point B also I'll do the same thing. See, like this. So now you tell me, okay, can I measure the angle between these telescopes or not? This one. I'm talking about actually this angle. This angle, let's call it theta 1,
sir.
and this angle is called theta 2. We can measure this, right, guys?
Yes, sir.
Okay, because it is on Earth. The telescope is in your hand, right? I'm rotating it to look into the planet, or let's say moon. No, we are rotating it after we are focusing it from that far away distant star. Okay, so I can measure that, And obviously geometry will allow us to imagine another parallel line like this. See guys, this one. So I will go like that, parallel to the two lines. Okay, so obviously automatically this angle is also how much, guys? Theta 1, and this angle will be called
Theta 1. Theta 2.
Theta 1 and theta 2. Is this clear, guys?
Yes, sir.
Yes, sir.
Okay, so now this theta 1 plus theta 2, I can call it theta, and this is what is known as parallax angle. Okay, parallax angle. So this is what we have, parallactic angle actually. Okay, not parallax angle, but parallactic angle. Okay, lactic angle. So we can measure this angle. That's one advantage now. Okay, now what is the other thing that we need? See guys, this, can I imagine an arc again or not? See this one, from A to B on Earth, right? I'm talking about this arc here. See, made by this one. See, it's like a circle, no? Part of a circle, right? Or sector we can call it, no?
Yes, sir.
And from A to B, what do you think, guys? From A to B, can we measure or not? What is this? Is it length of the arc or not? AB is what? Length of the arc. Length of the arc. Okay. What is AP? What is AP? If I tell you that is the length of the arc.
It's a radius.
Radius. Yes, radius. But in this diagram, what is actually that? Distance, right? Distance between what and what? Can I call it distance between Earth and the planet P or the moon or not?
Yes, sir.
Okay, yes.
Yes, sir.
And we already have measured something. We have already measured theta 1 plus theta
Theta
2.
2.
Yes.
Yeah.
So this is like theta. So now you tell me the relation between this, and this. What is the relation, guys? Yes. The angle theta must be equal to length of the arc, that is AB, divided by the arc,
Radius.
the radius. Sorry. That is not the length of the arc. What am I doing? What is the length of the arc, guys? Well, length of the arc is AB only. AB, and the distance, right? Distance is what? AP, I can call it, right?
Yes, sir.
Yes, sir.
Okay, AP. Okay, the radius. Yeah. Why I'm writing B? Okay, AP. Okay. So we have this. So what are we looking for? As you remember, we are looking for distance between what and what? Earth and moon or the planet. That means I'm looking for AP. That means I'll write AP is equal to AB by what? AB by theta. I think this is clear.
Yes, sir.
Okay, so do I know what is AB or not? First ask yourself, do I know what is AB? AB is a distance on Earth. I can measure this, right? The distance between 2 points on Earth,
Yes, sir.
we know that. Okay, so we know what is AB. Do I know what is theta? Yes, theta is theta 1 plus theta 2. So this is how you are going to measure what, guys? Distance between what and what?
Earth and moon planet.
Earth and moon, or let's say any nearby planet. Okay,
Planet.
yeah, so I will show you very quickly. Okay, another one also, and then I think I have to stop. Okay, so please check. That is your PDF number 7 only. Distance between nearby stars. Okay, so suppose distance of nearby stars. Okay, that means I want to calculate the distance between Earth and some nearby stars. Okay, so let me write that. Distance between what and what I said? Between Earth and nearby.
And
Planet.
No, not planet anymore. Nearby stars.
Yes, sir.
Okay, not far away stars, but let's say nearby stars. Okay, so check what we do. All of you will agree we have sun here, SUN. Yes, this is the sun. Then we have these 2 points, let's say A and let's say B. Okay, where our Earth is going to go round. No, you know, this is the path of the Earth, orbit of the Earth, let's say around the sun. Right now I'm drawing that. Okay, if today Earth is here at point A, okay, point A, if Earth is here today at point A, right, 6 months later, right, 6 months later, right, Earth will be here, right? Yes or no?
yes, sir.
Okay, because
Yes, sir.
12 months later it will continue. You know this. Okay, so this is the first position of the Earth. Okay, here first here, after 6 months Earth will reach here. Okay, so this is the orbit of the Earth, so that's what we have. Now imagine I have, this is the star. Okay, this is the star, nearby star. Okay, so you know what, I still will need reference for a far away star. Okay, so I'm again going to draw a star which is very, very far. A light is coming from the star. Okay, so that's why it's easy to focus. So this is our star. Say this is this star here that I'm trying to draw. Okay, it's a very, very far away star. So again, if I focus from here, it will look like this. It is here. If I focus 6 months later also, it will look like this. So these two lines will be parallel to each other. Okay, so what do you think, guys? Am I focusing on different stars or same star again?
Same star.
Same
Same
star,
star.
but it is a very, very far away star. Okay, then Can I focus from here when the Earth is there at this star? This is the star I want to calculate the distance from. Okay, so I can calculate this angle, right? Theta 1.
Yes, sir.
Okay, and then 6
Yes,
months
sir. Yes,
later.
sir.
Okay, for this method I have to wait 6 months later. I will go there. I'll measure
Theta
from
2.
here. I'll measure theta 2. Again, I
Theta
can
2.
imagine. Again, I can imagine what, guys? This one, no?
Theta 1, theta 2.
This is theta 1 and this is theta 2. So now again same thing. I think now you understand. I don't have to teach you, but let me just show you the base. See, the base here is this one, no? This one, right? This is like a base.
Yes, sir.
Okay, that is the distance between the two diametrically opposite points, and you can understand that is the diameter of this entire orbit that we have. Okay, so that's not a problem. So we know this, right? We know how far is this, right? I can tell you roughly also. Do you know how much is that? I told
Yes,
you last
sir.
class. How much is that? Anybody remembers?
Sir.
This looks like
2
one.
AU.
This looks like 1 AU. This looks another 1 AU. Okay, but please let's be clear. Okay, you cannot use this every time. I'll tell you why. Because Earth is like this. See, unless and until they tell you, you cannot use. This is the orbit of Earth around the Sun. This is the Sun. Actually, not even that. You know, that is also wrong. Sun is somewhere here. That's how it goes. This is an approximation again. Okay, the whole diagram actually. Okay, so you know what? Earth can be here. Okay, and 6 months later Earth can be here, no? Okay, so
Yes, sir.
yeah, approximately you can still take it as how much? Twice AU. Okay, but actually if you look, this is the diagram. Sun is never at the center of this elliptical orbit. Okay, this never happens. Can you say what I'm trying to say? Did you answer what I'm trying to say?
Yes, sir.
Okay, so
Yes,
sun, you will not find Sun here. Okay, here if you find Sun here, so very nice, no? But Sun is always, you know, where it's exactly at some of the this is called focus, actually focus of the ellipse or the elliptical path. Okay, so don't worry about this, but for the time being, unless and until they don't mention, okay, if they mention, you use this as twice AU. If they don't mention, if they don't mention, you can use twice AU. That's what I want to say. But if they mention, of course, don't use twice AU. Okay, they will tell you the value, maybe. Okay, what is the value of the angle, so that should be fine. Okay, but you understood again. See, now our job is again, you know what to find. Our job is to find the distance between A and the P, the nearby star. Let's call it P right now. Okay, in my notes I've called it S. Sorry, let me use S. Earlier I've used P. P. Now I'm using S. Okay, so again the same thing. I don't have to write anything anymore. I think you are clear with this, right? So again our formula will be different or same, guys. Exactly same, right? Can you understand?
Yes, sir.
Exactly same is going to be. Where is it? I don't know where I wrote that also now. Alright, where is it? How come? Who deleted? I didn't delete. Oh, it is here. What happened here? How got it deleted? Okay, fine. But guys, are you clear? How do we measure large distances indirectly? Is it clear, guys? Can I say that?
Yes,
Yes,
sir.
sir.
Okay. Then I think you got the idea. Now what you need to do is just go through those notes, check how it is done. Okay, then you can go to question PDF number 8 also, check. It's a very nice problem. You can do it. I'm sure you have to convert degree into minute or minute into degree. You check into radians. Finally, I'm telling you again, this theta measurements always in radians. Otherwise you cannot use the formula. Okay, this one, to use theta is equal to L by R, you always have to write this in radians. So please check. Even if they give you the angle in minute or arc second, convert into radians. That's it. Okay, then PDF 9 also you can do it, I'm sure. PDF 10 is very simple. It's just the smaller units of length, Fermi, angstroms, nanometer, micron, and the relation is given. Then PDF 11 is your NCRT questions. Some questions I just wrote there. Okay, so you can check, not difficult at all. Please check. Okay, that is PDF number which one? 11. PDF 12 I've already covered. Dimensions, I think you already have attended, no? Dimensions, guys?
Yes, sir.
Okay,
Yes, sir.
okay. Then
Yes,
I think it's fine. Okay, so yeah, any doubts you want to ask from here, you can ask me. I'm here for 1
Sir,
minute.
can you please
resend those PDF?
Oh, you did not get the PDFs?
No, sir.
Okay, you
I just got the dimension.
okay, who can help him? Somebody can help him from here. I'm going to start my class. Okay, that's why somebody else will help you. Okay, send you, from 1 to
Okay.
11. Send him from 1 to 11. Who has that? Jyotima, I think you have, no?
Yes, sir.
Okay, can you Dexway, right? I forgot your name also.
Yes, sir.
So what is your name?
Okay,
I
sir.
forgot.
Yes, sir. Biswadeep, sir.
Oh, Biswadev. Oh, acha. Biswadev, Jyotima then will send you. Okay.
Yes, sir.
Okay. Then Jyotima, yes.
Sir, do we need the numericals, sir?
Do we need the numericals means?
So in page this 19.
Page 19. I have no idea right now. Right? I don't have the book also right now with me. Can you show me
sir.
page 19? Can you show me page 19 numerical?
Okay, sir. I'll send you photos, sir.
Okay. Then I'll just tell you, okay, whether to do or not.
Yes, sir.
Okay. Yes.
So
Abhijit.
you'll do measurement of mass also, sir.
Measurement of mass. You try to just go through once. Okay, just go through once the entire
Yes, sir.
topic. Okay, there's not much there actually. That's why I don't used to teach. Okay,
Yes, sir.
let's wait for your teacher. Your school has started classes.
No, sir. They have just created